a presentation on Industry 4.0 and and the relevance of statistics. I'd like to begin to introduce what Industry 4.0 is all about. Now, the Industry 4.0 is also the fourth industrial revolution in history. It is synonymous with smart manufacturing, and manufacturing had revolutionized across the years. So, and this is the fourth of the revolutions that we've seen in the manufacturing industry. It started from the 18th century towards the later part of the 18th century, where the revolution was with steam and water, and then manufacturing mechanical facilities had been one of the major revolutions that had happened in that level. Then up until the late 20th centuries, we had another revolution in manufacturing industry by the introduction of assembly line, and some of the facilities that aided this revolution was we had electricity, we had gas, we had water, we had telegraph, we had roads. Those were facilities that did this. Now on to the third industrial revolution. This happened towards the later part of the 20th century, and this basically was the revolution with regards to the introduction of mobile telephones. We had telephones, we had machines, NC machines, that were part of the major backbone in the introductions of the third revolution. This was towards the later part of, we had electronics, right, that helped. Lean manufacturing was introduced. Then to the fourth industrial revolution today, which is, like I said, is synonymous with smart manufacturing, is basically the realization by digital transformation in the field of manufacturing, or the manufacturing industry. Let's take a look. These digital transformations were achieved by development of certain technologies, which generally can be categorized into five major categories. Now, what you see here is the smart factory. Now, so that industries that have now incorporated manufacturing with the with incorporated smart manufacturing are usually called smart factory. So it's not a big deal, the name that you see there. So some of the things that are cut across it are gonna be a few things I'll talk about in few minutes. That there are a few things I'll talk about in few minutes, and then I will talk about them: big data, cloud computing, AI, cyber physical system, augmented reality, additive manufacturing, virtual reality simulation. Some of them are examples of the major categorization, while some of them are the major categorization themselves. Next is the Internet of Things, basically the embedding of sensors, softwares, processing units in physical products that are being manufactured. This will help the manufacturers get data from the utility or the usage of some of those products, and make for optimization of their processes, their products, and upgrades. And also, this also brings a lot of comfort to the user of the product in question. So for instance, in the picture you see there, the lady with the different gadget having embedded sensors in most of her gadgets. From the comfort of where she's seated or standing, she could control those devices. But more than just controlling and giving comfort to the user, it also helps manufacturers in making database decisions, and improving the quality of the product. So again, the next is on-demand computing. This is basically the availability of data or usage upon generation. Now, when data are being used, when some of those, for instance, I would think I will be taking reference to the the Internet of Things, like talked about. Sorry, like I talked about in this graphic picture. Now, some of these things, do you see the connections to the devices on our hand? These connections are basically data. These are is the controls to it, and also data are being transferred. data being collected by the utility of those gadgets in the software or device that she has in her hands. Now, the transmission of these manufacturers can take on the data being produced by these devices, stored in the device in her hand from a particular storage architecture, a data lake, a data warehouse, basically cloud computing, maybe via the cloud. Now, the transmission of the data generated from some of these gadgets to the cloud where the manufacturers can have access to it is basically on demand computing. So, in a versatile or in a more larger scale, you have edge computing. Next, we have cognitive computing. This is basically the introduction of artificial intelligence and machine learning in manufacturing. And this is basically where you have computer algorithms mimicking the functions of the way the human brain functions in order to improve decision making in manufacturing and optimization of the products and the processes manufactured by the companies or the manufacturing products or the smart factory, if you like. Next is cyber physical systems. Cyber physical systems, these are mechanical systems controlled by computer based algorithms. So you could see from the picture behind that the engineers are basically observing, they are seeing the process whereby this cyber physical system, I really love this, where the mechanical system themselves are just controlled by computer based algorithms to manufacture and produce things in and of itself, right? So you begin to have, and examples of these things are additive manufacturing. Example of commonly known as 3D printing. 3D printing now produces they even use it to build houses right now, producing prototypes of houses. It produces some of the mechanical gadgets of a car, of different machines. It does a whole lot. It does a whole lot. This is one of the advances of the fourth industrial revolution. Next is the data analytics. This is basically the transformation of these raw data from coming from products, coming from real-time monitorings, coming from different kinds of places for to transform them to actionable insights and trend, converting them to reasonable informations that can be used for by the manufacturers for development, for optimizations. This is what data analytics generally is all about. Now, some of the key contributions of statistics. Remember, the focus of this presentation is Industry 4.0 and the relevance of statistics. How does statistics influence and become relevant in the fourth industrial revolution? Here are some of the things that it does. Next, the first is the sensor data analysis. Right, this is basically making analysis from some of those embedded systems, embedded softwares that are in some of the products that are being produced by the manufacturers, and analysis done on them to produce informations that are actionable and trends, to see trends and know the workabilities and evaluations on some of these products are called data sensor data analysis. Now we have real-time monitoring. I really would love to talk about this. It's also basically where you get analysis, continuous analysis done in real time, so that when manufacturing is being carried out, that we can monitor the manufacturing process, we can see the outputs from some of those processes. We can optimize it by making analysis continuously on the spot in real time. This is amazing. This is amazing. Then you have machine learning and artificial intelligence. This is basically data science algorithms used for optimization. I talked about it earlier when we talked about cognitive computing. Basically, the introduction of some of these processes and then helping to optimize the product and the process optimization in manufacturing. We have things like supply chain, and when problems are detected or are complained of, manufacturers go on to check where is the problem coming from, how did the problem come about, when did the problem, when did it start. And then when they track these things, many times the first things they begin to check is the process. Where in the process did this problem develop? When they track it, they solve the problem, they optimize the process so that the problem does not continue. And the analysis in these cases are called process optimization analysis. Then some of the statistical tools and techniques used in the industries are regression analysis, time series analysis, multivariate analysis. I think it's a good time to stop and ask that some of these lists are not in any way exhaustive. This is basically to give an umbrella view. This is basically to give a panoramic view, or for everything that happens within, or the relevance of statistics in industry 4.0. Because I mean, if we are to go by it, I don't know when we are going to finish, because it's a whole lot. Now, in regression analysis, this is basically one of the tools that causes to identify the root cause, the effects, waste, and all of that. It helps to identify, basically, to show what variable is responsible for these variables, and the relationship cut across those variables in the product output. Next, you have the time series analysis. Is a statistical technique largely basically used for identifying trends and knowing exactly, making forecast of the future, the product forecast. And this helps company to stay in the market, because I mean, without this, the company will soon lose relevance, and I mean, they are completely out of market. So this has been one of the major cornerstone, one of the major milestones in the fourth industrial revolution. Then we have multivariate analysis. This is basically used in complex manufacturing, when there are multi variables that are responsible for the making of many of the products. And in these kinds of complex manufacturing, multivariate analysis are used in order to get this done. And some of the tools that you have are R. R is a programming language for statistical data analysis. We have Python. We have SPSS is a statistical package used for data analysis. We have Excel. We have Power BI. We have Azure. We have many other tools. This is just to give an example, right? So what's a case study of a smart factory implementation? So the overview is that a mobile phone manufacturing company decided to transform their traditional manufacturing process to smart manufacturing. What was the goal? The goal was basically to improve user efficiency and improve overall productivity. How did they get this done? The company installed IoT sensors on different components of the mobile phone to collect data like temperature, pressure, and other critical parameters of the mobile phone. Data from these IoT sensors were transmitted to the cloud for real-time analysis and monitoring through wireless connections, of course. Then statistical analysis were carried out on some of this data derived from the IoT sensors, and basically this was to optimize production and tailor the products to user preferences. What was the result of this? The of this transformation into smart manufacturing? Basically, the company had improved efficiency, reduced downtime, enhanced product quality, thereby increasing their visibility and acceptance in the market. And this overall cost increase, it cost for a lot of increase in their manufacturing. Next was basically, so what's the conclusion of the whole thing? The conclusion was the statistics is a cornerstone in the fourth industrial revolution, driving innovation through data-driven decision making. The rapid growth experienced in the industry has caused for improved statistical method, and will continue to push for more advanced methods and unprecedented technological advancements. This is a major role in the fourth industrial revolution, statistics, of course. And the picture shows you how the interconnections of things are wrought. Thank you so much. I'd like to have you again. See you next time.